So I'm going to be grading your unit plan on a 35 line rubric. And just like with any rubric that we use, the one that you'll use during student teaching, the one on the Ed TPA, these rubrics are really not designed for you to get all fours. All right. According to the grading standard that Reuter created, if you get all threes on the rubric, that's a 90. All twos is a 70. Okay, so that's kind of your minimal competency for the course. If you get half threes and half fours, that works out to being almost a 97. All right, so you're probably not going to get a lot of fours. That, when it says accomplished, this is talking about being an experienced teacher, which you're not yet. But I think there's some places where people will be able to, get a 4 here and there. Definitely a few places that, don't be upset if you get some 2s. There are definitely some places that I feel like getting out of the 2 range would even getting to a 3 would be a tall order. So anyway, I had this grand plan. If we were in class, I was going to put you in groups of 2. I was going to do a jigsaw where each group would take 5 lines on the rubric and kind of analyze those 5 lines, and then we would come back to a class and everybody would report in what they gathered from the rubric. All right, so obviously we can't do that. So what I tried to do to help you with this document, because it's very overwhelming to try to sit here and read 35 lines that have 4 descriptors per line and make sense of what you're reading. So what I tried to do, obviously I've highlighted things, and I'm trying to make it so that you can kind of do a quick read in about 10 to 15 minutes of what are the things that you should focus on. All right, because I think writing the unit is one thing. I think understanding what is required of you, that's like a whole nother exercise. So anyway, going through this then, looking at the things that I highlighted, first of all, in your unit, you've got to have some mathematical activities and investigations, all right? Using technology is a great way to do that, but we've talked a lot about how to get the students playing with the math, all right? So that you're not just dispensing rules and have guided note sheets where students are just doing problems. All right, but we have some investigations set up where students are playing with the math and drawing their own conclusions. And this next line, talking about problem solving, so that's going to be an important part of Ed TPA also. We know that as good teachers, we have to be encouraging our students to solve problems. I feel like it's hard on a unit plan to showcase a variety of problem solving skills. And use a variety of strategies. How do you showcase that within a unit plan? So I think that's hard. But if you can make some references to where your students are problem solving, that way I could at least give you a 2 or hopefully a 3 for this line. Another thing that is important, and this is going to come up several times on the rubric, and one of the things you're going to notice about the rubric is there's a lot of repeat. But anyway, connecting to real world contexts. And that kind of goes along with connecting to students' daily lives also. So we've talked about how to do that, and you guys did a great job writing a reflection where we talked about how to modify, that was one of the first reflections, modify a learning task to be relevant to students' lives. But if you can connect out to the workforce, or things in the students' community, any of that is connecting math to real world contexts. All right, so again, that's something I have to look for. Real world contexts that allow for student discovery again. So you're not just dispensing information to the students, you're letting students play with the math and discover things for themselves. So the next one, mathematical communication. So again, how do you show this on a unit plan? All right, and so you might say things like, well, the students are going to work in groups, therefore that means that they're going to be critiquing the other students' arguments. That's not quite enough. So you need to have something in your plan where you plan for the teacher to present something. Again, so it's students playing with the math, the teacher to present something, and then the students to try to critique that argument. For example, let's say that you're doing some geometry proofs, and the teacher says, if I show that I have a parallelogram with one right angle, all right, and I only prove that one angle is right, is that sufficient to prove that the figure is a rectangle? Okay, and then that would be something that students would, critique that argument. So that some of them would probably say, no, you have to prove that there's 4 right angles, which you actually don't, because as soon as you have one right angle and you know properties of a parallelogram, then just proving one right angle is actually sufficient. All right, but something like that, where the students have to analyze an argument, all right, would be something you'd want to include at some point. And some of these things, if you can just show me one place where you did it on some of these, that's enough to at least give you a 2 and maybe even give you a 3, right? If you can just have one good example in your plan of where you're presenting the students with an argument and they're trying to critique and analyze that argument. So coming up here, represents and models generalizations. All right, so that's analyzing patterns. And I hope I did a really good job of illustrating that for you on the most recent lesson you watched in my pre-calc class, where you saw me develop that formula for finding interest. All right, and so we looked at the generalization of, well, if it were compounded twice a year, well, what if it were 4 times a year? Well, what if it was monthly, right? And I kept working that through to show students how we develop a formula from a pattern. All right, and so that would, if that were my unit plan, I would score myself well on this one, right? Because I modeled that generalization and helped the students recognize the patterns of the pattern with repeated reasoning. All right, and that's one of our SMPs. So this one I'm expecting us to do well with. You guys are doing fantastic on multiple representations. So again, your unit plan needs to feature multiple representations with connections between the representations. So I'm optimistic that we might get some 4s over here. So other things that I have to grade you on is using appropriate vocabulary and symbols. So on your test and in your lesson plans, I'm going to be looking for precision and accuracy with your symbolic representation and your vocabulary. And there's another one on language in a minute. So yeah, they feel sort of out of order to me, because here's language and then here's the other one on language. We jump down here. But use language to express ideas precisely. So what that means is I've heard many student teachers ask their class, class, what does supplementary mean? And the students say, supplementary means 180, right? And that means that they kind of get what you want them to get, but that's not a precise way to say that. So students should be saying 2 angles are supplementary when their sum is 180, okay? But the imprecise way would just be to say things like supplementary means 180, or I've heard students say things like triangles have 180, right? And then the student teacher will say, oh, very good, triangles have 180, right? And again, we need to be precise. The sum of the angles in a triangle is 180 degrees. All right, so I have to grade you on precision in your language. And that probably will come up a lot in exams, right? Your test questions need to be worded precisely. And back to this one. So again, mathematical models derived from a variety of real world contexts. Again, this is probably somewhere that even getting a 3 is a tall order, right? Because you have to talk about a variety of real world contexts. If you have 1 or 2 real world contexts within your unit plan, I think that's doing pretty decent, but that would only get you probably a 2, right? Because to get to a 3, you have to have a variety. of them, which is tough to do. I certainly don't do that in my own teaching, right? I give some real world examples, but I would not say every unit I am providing a variety of real world examples. So this one, making connections, right? Interconnectedness of mathematical ideas. So again, connections to real life, but also here connections among mathematical ideas. All right, so a couple things about this one. This one you want to show that one plan is well connected to the next day, which is well connected to the next day, and so on, so that there's connections within your unit. But also if you can make some connections to other areas, right? Other topics. For example, say you're teaching them the 30, 60, 90 right triangles, right? And the rules about, oh, this, this side is always half the hypotenuse, and this side is always radical 3 times the other side. If you're doing that, that connects to similar figures, right? Because every 30, 60, 90 right triangle is similar to every other 30, 60, 90 right triangle. That's why all the sides are always in the same proportion. All right, so that would be a case where similar figures is not part of your unit, but you should still connect to it because it's very relevant to that particular lesson. So something else you have to do, this is asking you to show how your teaching intersects. So the domains are like the topics. All right, so the domains are your, that would be like your daily standards, and you have to show how they intersect with the standards for mathematical practice. Okay, so the SMPs. And the rationale, so you do have to give a rationale for your unit. We have to understand the value of the unit. So for example, if you are teaching orthocenter and circumcenter of a triangle, right? And why would I want to find the orthocenter and the circumcenter? So some of those points of concurrency in the triangle, it's like, okay, great, this is how you find those. Why does it matter? All right, and I know that I've observed student teachers before where I've said to them, why does this matter? Why do I care if I find the orthocenter? And they actually look at me and are like, I don't know. My cooperating teacher said I had to do this lesson. I don't know why it matters. Okay, so it's important. You have to communicate to your students why it matters that you learn things and what the practical implication is of what you're teaching them. So you have to have that clearly spelled out as part of your unit plan. So moving on here, this line, basically it's just asking you, can you cite the correct standards? Okay, and identifying how research was used in your plan. So there's a couple different lines for research, and with all the research articles that I've given you that are very generic, I hope it's easy to have some research citations on your lesson plans. Remember, when you cite a research article, you have to tell me how that research article was actually used in the planning of your lesson, right? How it influenced the planning of your lesson. Because here's a place where it says, like, this is basically saying, can you identify research that's relevant to your unit plan? But this one is actually asking you to say, because of what I read in this article, I changed my lesson, right? Because the research said that when I teach functions, multiple representation is so important. Therefore, I modified this lesson and I added in more different, a greater variety of examples in order to satisfy an example for each one in the rule of 4. Okay, so that would be the kind of thing you would want to do for this section. So let's see. I had another thought about research, and it went out of my head before I could say it. So another thing that people have been asking me, because you hear the word research, and I'm really impressed that everyone in this class understands what is real research and then what is just a peer-reviewed article. But all of these places where it's talking about research, a peer-reviewed article is fine. Because first of all, I think every single one of those peer-reviewed articles cite an actual research study. Okay, so the term research here is used a little bit more loosely than it was in the research project, where your research article actually had to be based upon a study. Okay, so when it says research, it just means basically anything that's published by a reputable source can be considered a research article. Okay, so next line, unit plan includes a wide variety of instructional strategies. I mean, how many strategies do we use in math? Strategies we would use would be group work, direct instruction, technology, an activity, right? I mean, how much other variety do we really use? Maybe there's some sort of game, maybe you do something on, maybe you use marble slides, right? All of those things add variety to what you're doing. But I feel like, in my pre-calc lessons, I don't use a wide variety of instructional strategies. So again, if you just have a couple different strategies, some group work, some direct instruction, maybe a game, some sort of activity, some sort of technology, that'll give you a 3 for that section, or for that line of the rubric. So on your unit plan, you have to talk about differentiating instruction. And not surprising, there's a line about math-specific instructional technology. So you definitely want a technology day in your unit. And let's see, build on conceptual understanding and procedural fluency. So we are focusing on, and this will be also very important for the EdTPA next fall, is how are we assuring that students are also developing conceptual understanding rather than just, getting answers right and plugging and chugging. All right, so that will be important. And this has come up before, right? Activities and investigations that require significant communication about math. So you have them in groups investigating something and trying to write a conclusion to what they observed in their investigation. All right, if you can do that, that'll give you a good score on this line. Mathematical connections with other content areas. Again, that's kind of tough. I mean, if you can have an example that connects to science, that would be good. Or daily life or the workplace. Again, we saw this in another line. A lot of these lines are somewhat repetitive. But again, if you can just do that in 1 or 2 places, I can at least give you a 2 and hopefully even a 3 for doing that. So you are going to design both formative and summative assessments, and you are to vary the levels of difficulty. All right, and so we talked about that in our lesson about differentiating instruction, is that maybe you have a ticket out the door where students only have to do 1 question, but they self-select, right? They give themselves a happy face, a medium face, or a sad face for the day, and then you have 3 different levels of questions that the student tries the question based on where they felt their understanding was. Make sure on your end of the chapter test that you have some easier questions, right, that you expect most students will get. And then hopefully on your test, you have at least 1, maybe 2 questions that are very challenging that only, your top students in the class are going to get right. And then something else, again, this is kind of hard to showcase in a written unit plan with imaginary students. But you need to talk about how you're going to use assessment to inform instruction. And I'm probably going to do some double dipping with the couple reflections on assessment, where I'm going to ask you to talk about the ticket out the door that you plan to include in your unit plan, and ask you to talk about a specific plan for what if you do this ticket out of the door and the students do terrible on it, right? What are you going to do? So where you might talk about this in your unit plan is on the pre-assessment data part of the unit plan. That might be a good place where you talk about you know, based upon the ticket out the door, if students showed mastery, then I will proceed as planned. If the students struggled on the ticket out the door from the day before, then I'm going to add this example to the beginning of my plan to show that you are using the assessment data to modify your lesson. All right, so that's what you have to show to score well on that line. And gosh, we're only like halfway through. All right, so this really says the same thing, right? Unit plan uses formative and summative assessments to make instructional decisions. All right, so your plan, and again, it's hard to show this for imaginary students. This would be much easier if you were in a real classroom working with real students day after day. But you have to try to find a way to communicate to me that you are at least thinking about what you would do differently in one lesson versus another, depending on whether the students aced the ticket out the door or everyone bombed the ticket out the door. So let's see, we've got connect new learning to prior knowledge and experience. So we've talked about that already, connections from lesson to lesson within your plan, but also connecting to, you know, other areas of math. So an example where you might connect is, say you're in algebra and you're teaching them to add like terms, right? And you might connect that back to the fact that every time we add anything, we need like things, right? If we're adding whole numbers, you only add the tens to the tens and the ones to the ones and the hundreds to the hundreds and so on. When we're in fractions, we only add when we have like denominators, right? So to add, we always need like units. To multiply, we never need like units. All right, I did a lesson on this in your class earlier in the semester. So that might be a place where you're making connections to prior learning and experience. And again, some of these are so repetitive, I feel like we've talked about everything here, so I didn't highlight any more. And then the multicultural example, that's going to be important, that you have at least one place. If you give me just one example, that'll give you a 3. But one place, so I gave you the made-up students, and I want you to have one example where you use something from their culture in an example in your lesson. So this one, again, how do you show this in a written plan? So this line says, demonstrate ethical and equitable treatment of and high expectations for all students, right? How do you show that in a written unit plan? But I think that I will see this and be able to score you well on this if you talk about differentiation appropriately. Because when you're differentiating and when you're not just meeting the needs of the lower students, but you're also addressing the higher students as well, then what you're doing is meeting the needs of the individuals in your class. All right. And that's how I would argue that you are showing me that you have fair and equitable treatment, right? Because you're meeting everyone at their ability level, and you have high expectations for all if you're challenging even, you know, your highest and your strongest learners. So we have to use instructional tools. All right, so instructional tools, that's a little different than technology, although technology does fit under the umbrella of instructional tools. But instructional tools don't have to be technology, or they don't have to be mathematical technology. So that might be the smart board, or, you know, rulers and protractors, right? Those are instructional tools. What are other examples? You know, even calculators are instructional tools that you might be using. So you want to think about, and again, this sort of goes along with variety of instructional strategies, right? That you're using different instructional tools, and you know, you're not just doing the same pencil and paper thing every single day. Now, when you talk about the mathematical technology that you use, and this is part of, again, something you're going to have to describe next fall when you do your technology lesson, you have to talk about both the pros and the cons of technology. All right, so what was gained by using technology? but then what were the limitations, right? Because not all, just because you're using technology doesn't make everything in your lesson perfect, right? So what was limited about, trying to incorporate that technology? So it can't do everything for us. And so what were the limitations? So let's see, we're getting there. So moving from concrete to abstract, I feel like we've talked about a lot about that. So this is dealing with like appropriate pacing, right? Like scaffolding. This line's hard because there's so much in the line. To be honest with you, sometimes I don't even know how to interpret the rubric when there's too much happening in one line. So we've talked about math-specific technology. That's important. And all of you on your lesson plan, you're just going to write, I was in social isolation, so you all get a 3 on how you worked with others. And finally, we're almost to the end. So we've seen this a couple other times in the plan, asking about research, but more than just listing an article, but really making it clear how that research article influenced your instruction. Okay, so if you can do that at a couple points in the plan, then I can give you a good score here. And finally, they require you in the unit, so you want at least one technology day, and then you want a day where you can say, I'm doing an activity that I got from either this NCTM article or this TI website, but you took some sort of a resource from somewhere else, all right? So the unit plan is requiring you to show that you can search for resources and find a resource at some reputable website and incorporate that into your unit plan, okay? So it's a pretty tall order to be able to do all of the things in the 35 lines, but we've got this. I'm eager to see how well you guys are going to do with this. You've got this.